In reaction 1 here, we have hydrogen peroxide already in the test tube. And we're putting a small amount of manganese dioxide. It's a black powder. And then my thumb is on the top of that test tube in order to keep the gas inside. So notice that there's some bubbling that's happening. And now we've got a lit splint. And let that gas build up a little bit more. We're going to put a glowing splint into the test tube here. So, and when you put a glowing splint in there, you see that it relights, it bursts into flame. And the reason for that is oxygen gas is being generated here. So this is the test that we do for oxygen gas. A glowing splint relights, and that indicates the presence of oxygen gas. Here in reaction 2, we have some hydrochloric acid already there in the test tube. And then a strip of magnesium metal. It's flexible, malleable, like most metals are. So dropping the magnesium into the test tube reacts vigorously. I put my thumb over the tube again to keep the gas inside. You can see it's bubbling and lighting a splint. This time we're going to put the lit splint. It's actually burning in there. Listen carefully. Okay, that barking or popping sound is the test for hydrogen gas. So when you take a burning splint, put it in the test tube, it makes that popping sound that indicates hydrogen gas. So here's the reaction, guys. That's it. It's happening. In reaction 4, we're going to take a piece of copper. There it is. And put it in the hottest part of the flame right above that bright blue cone. So remember the appearance of the copper beforehand. We're going to look at it again. It does not look the same. It is not the same color. It's gotten very dark. So something has happened. In reaction 5, we're going to take another piece of magnesium, similar to the one we dropped in the test tube before, but this time put it once again in the hottest part of the flame. And take a look at that product. So now it's kind of like white and powdery, ashy. So before it was metal, and now just going to poke it a little bit to show you that now it's kind of brittle, breaks apart easily. So it's clearly not the flexible metal that it was beforehand. So copper 2 sulfate is this turquoise solution that's in the test tube already. And then sodium carbonate is in this bottle. It's a clear, colorless solution, so you can't see into the bottle too well, but it looks just like water. So you can see a bright blue, bright turquoise solid has formed in the bottom of the test tube, a precipitate that was not there before. So we're going to take some copper sulfate in a pipette and put it on these pieces of zinc on this watch glass here. So the zinc is silvery, shiny, like metals are. So this is that turquoise colored solution. You've just covered the zinc metal pieces in that. So this is a little hard to see, especially given the background, but hopefully you can see forming. There's a solid forming on the surface of that zinc metal, and it looks very dark. It's kind of blackish. So it's not shiny anymore, and you can actually kind of see the particles themselves on the surface of those zinc squares. Just for some comparison, here's the original zinc. So, oh, it slid. Come back here. There we go. So that kind of shiny, silvery, and you can see the ones in the liquid are no longer that shiny, have that shiny look because they're reacting. In reaction 8, we've got calcium nitrate already in the test tube. It's a clear colorless solution. And we're going to take the sodium carbonate, which we used in reaction 6 also. Same stuff, also clear colorless, looks like water. That's in the pipette here. We're going to drop it into the test tube. And once again, we have a precipitate, a solid formed. The solution got cloudy, so that wasn't there before. So we've created a new substance in that test tube.